So to jump right in, we're going to look at two of your vocabulary words. Absolute value, remember, is just the distance that a number is from 0. So remember, distance is always positive. So if you're thinking about your car, you're driving, even if you're driving in reverse, your miles are still being added on because it's still a positive direction. So absolute value is the distance from 0, which always results in a positive number. So the absolute value of -4 is 4, because -4 is 4 spaces away from 0 on a number line. Same idea is that the absolute value of 4 is also 4 because it is 4 spaces away from 0. Our other term that you want to be familiar with is additive inverse. This is a mathematical way to say opposite, but technically an additive inverse is a number when added to some given or specific number results in 0. So additive inverses are two numbers that you add together and they give you 0. So for example, the additive inverse of a 5 is -5 because 5 plus -5 is equal to 0. So opposites is the casual term, additive inverse is the mathematical term. You will want to know both. Here's a visual of just kind of like a graphic organizer of what an integer is. So to describe what an integer is, it's really just your positive and negative whole numbers. So if you remember your whole numbers and what that looks like, these are just the positive and negative versions of that. It helps to sometimes picture it on a number line. So typically integers are what we're using as our numbering for our number line. So some examples of what an integer would be, we could have -16, 0, or 736. Those are all examples of integers. Some non-examples then would be 1/2, the number pi, or you could do -0.3 repeating. Those are not whole numbers, even though they are a mix of positive and negative, they're not whole numbers, so they are not integers. One thing that we want you to remember with integers is how to compare their values, which ones are more, which ones are less. And so we're going to use a visual of actually graphing on a number line in order to show that to you. So here Stephanie and her friends played a question and answer video game. Their scores at the end of the game were 1, -5, 0, 4, and 2. Graph each score and then list the scores from least to greatest. If you want to try to list them in order before you graph them, that might be a good practice for you. Otherwise, graph them and that will lead us to what their order is from least to greatest. Go ahead and pause real quick and just get those graphed. So once we graph them, notice now we can read the graph from left to right, and that will give us the order from least to greatest. So our least to greatest order would be -5, because that's the first one I see here on the left, and then I'm moving forward. So then we have 0, 1, 2, and 4. So our next question is, how does graphing the values relate to ordering the values least to greatest? And so basically, if you graph your numbers on a number line, you should be able to read it from left to right, least to greatest. So left means the least. So the farther left a number is on your number line, that is the least value, or the smallest. So what I want you to do is take a minute, go ahead and pause, take a moment to write your own definition there of how does graphing the values relate to ordering the values from least to greatest. Explain that real quick and then we'll jump into the U-try. So now that you have kind of written your own definition of that, we're going to go ahead and put it to practice. So we're going to look at this U-try. The recorded highs in degrees Celsius at Niagara Falls from February 21st to the 28th of a recent year are 4, -1, 2, 6, -6, 1, -5, and 0. Graph each temperature, then list them from least to greatest. Go ahead and do that, pause the video, and then we'll jump back into everything. Great, so here you should have graphed those points. They should match the ones that you see now. And then the order from least to greatest, or from left to right, is -6, -5, -1, 1, 2, and 4. So remember, with negatives and positives, even though 6 looks like it's a bigger number, because it's negative, it's the smallest number, whereas the positive 4 is the biggest. So now we want to look at how does this relate to real world things? How would we use this? How does it vocalized right in the real world? So if we're looking here at number 1, what we're supposed to do here is write an integer for each situation, then identify its opposite or its additive inverse, and describe its meaning. So number 1 says we're 2,972 feet above sea level. So one thing that we want to recognize is that not all the time are we going to have like the numbers written, but we're going to have words that lead us to that. And so here our key word is going to be above sea level. So that is telling me, since I'm above, I'm high, I'm going to be at a positive 2,972 feet. Well, now our additive inverse, or the opposite, would then be negative 2,972 feet. However, when I'm describing that and explaining that's meaning, I'm not actually going to use the negative. I'm going to use words that would describe that to be negative. So if we're looking at opposite number, positive, opposite is a negative, then we want to go back to what led us to believe that it was positive, which is the word above. So what's the opposite of above? It's below. So now our description is that we're going to be 2,972 feet below sea level. And it's also really important to recognize what 0 would represent in all of these situations. So in this particular situation, our 0 would represent sea level, exactly at sea level. But then when you go below the water, right below the sea level, then you're going to get negative. And when you are above the water, above that sea level, it's positive. So 0 is our sea level. And so notice I didn't write negative 2,972 feet. I wrote, it looks like a positive 2,972 feet, but the negative comes in when I describe that it's below sea level. So that's an important thing to distinguish between. So if we look at this next one, 33 feet deep. So here our keyword is going to be deep. That means we're probably under. We're digging a hole underground. So our integer here is actually going to be negative 33. Our additive inverse, or our opposite, is going to be a positive 33. So again, what's the opposite of deep? Probably high. And so this means we're going to be 33 feet high. So if we're talking about like digging a hole, 0 would be the ground level. Anything below that, going deeper, is negative. Anything building above that is positive. All right, go ahead and flip to the next page, and as you do, pause the video so that you can do your U-tries. So go ahead and pause the video, try to find the integer, the opposite, and the description. All right, so hopefully you saw that the key word in number 1 would be a loss of 8 yards. So if you're losing something, that means you're kind of getting rid of it, you're subtracting it, you're taking it away. So it's a negative 8. Opposite of that would be positive 8, and so the opposite of a loss is a gain. So if you're not losing something, you're gaining it. So it's a gain of 8 yards. Number 2, deposit. That means you're putting money into your bank so that you're getting more money that you're saving. So deposit is a positive thing. The opposite of positive 15 is negative 15, and that means you're taking it out of your bank account, which is called a withdrawal. So that's what that means. So next what we're going to do is we are going to look at evaluating absolute value expressions. We want to kind of look at your absolute value symbols, kind of like parentheses, and so you want to do those first as you do what's inside of them first, if that's an option. Otherwise, you're just evaluating. The absolute value, guys, is a mathematical operation. So it is a step that you have to do even if it doesn't seem necessary. And we'll explain that here in just a moment. So when I'm looking at this example up here, simplifying the absolute value of -4 minus the absolute value of 3. We want to show that we're taking the absolute value of each individual number. So the absolute value of -4, remember that is the distance that is away from 0, which is 4 spaces. So the absolute value of -4 becomes 4. My subtraction sign's not going anywhere. And then the absolute value of 3 is 3. So now this problem becomes 4 minus 3, which is 1 as your final answer. Now pay attention to how this next one differs a little bit. Here, just like I said before, we want to do, it's kind of like parentheses in a way, that we want to do what's inside of them first. And so when I'm looking here, I'm not going to do anything with the absolute value yet because I have something happening inside of them. And so I'm actually going to keep my absolute value symbols while I actually evaluate the inside. So what is 5 plus 1? That would be 6. And now, once I've done what's inside the absolute value, I can actually evaluate the absolute value. And so from here, then my answer would be a positive 6. You cannot skip this step. Do not. We will count it wrong because the absolute value is an operation. It is a step. So even though it seems silly to write that, even though you know it's going to be the same answer, it does not matter. You have to show it in its own separate step. All right. So now let's kind of think about this. How do the processes for the two examples above differ? So how are they different and why is there that difference? Go ahead and pause for just a moment and kind of jot down some ideas there. Now, if you want to write something different, that's totally fine. This is just a quick idea of what happened and what the difference was. In the first example, you had to evaluate the absolute values first. That was the thing you had to do. You couldn't do the subtraction in between until you evaluated the absolute values. But in the second one, we actually had to do the numerical expression first, the 5 plus 1, before we could evaluate the absolute values. And that difference is just there because of the way that it's written in the order that it's written. So you have to really pay attention and kind of apply that order of operations idea to that so that you can evaluate them correctly. So to see if you have a good understanding of what that means and what that looks like, I want you to go ahead and pause the video and do the U-tries. Make sure you write out the steps exactly as you should. Remember that absolute value is a step, just like adding a number or subtracting or multiplying. You have to show it in its own step. So don't forget that. Go ahead and pause the video and see what you can do on the U-try. All right, so hopefully you had that you did 16 minus, and then you had to evaluate the absolute value of -9, which is a positive 9. And so then our problem becomes 16 minus 9, which is 7. In the second one, we have to do 13 minus 8 first. So 13 minus 8 is 5, and then we have to take the absolute value of that 5. So you cannot, guys, skip that step. You will have to redo your work. You will not get full credit if you do not show that step. As simple or as silly as that seems, it is important in showing what that absolute value is doing. So then you should have the absolute value of 5 and then the actual final answer of 5.